Welcome to Sumantra Codes, where we learn Python programming in a fun and easy way. This is episode 6 of our series, and today we are going to learn about Python sets. In this video, you will learn what sets are and how to create and use them, and what are the differences and similarities between sets and other data types. So what are sets? Sets are one of the built-in data types in Python that are used to store multiple items in a single variable. Sets are similar to lists, but they have one major difference. Sets are unordered and do not allow duplicate values. This means that the items in a set do not have a specific position or index, and you cannot have two items with the same value in a set. Why do we need sets? Sets are useful when you want to store a collection of data that is unique and does not need to be ordered. For example, you can use sets to store the names of the students in a class, the colors of a rainbow, the genres of a movie, or any other data that is distinct and unsorted. How do we create sets? There are two ways to create sets in Python. The first way is to use curly braces and separate the items with commas. For example, fruits is a variable. Inside curly braces, I am assigning apple, banana, and cherry. So this line will create a set of fruits having elements apple, banana, and cherry. Let's print fruits and run it. So you can see the output over here is set of elements inside curly braces, which we call set, and the elements are cherry, apple, and banana. The second way to create a set is to use set function. This function takes an iterable object such as a list, a tuple, a string, or a range and converts it into a set. For example, let's create a list of numbers 5, and now from the list of number, using set function, we can create a number set. Let's print the number set and run it. Let's give a comment, create a set from a list. Now let's create a set from a string. We define a name variable, Sumantra, create a name set using set function and passing the name variable as a parameter. Let's just print name set also and run it. So here we have created two sets, number set and name set. The first one contains the same element as the list of number, and the second one contains each character of the string name as an element. Notice the order of the element. It has been changed and only A has been used once. So note that if you pass an iterable object that contains duplicate values to the set function, the duplicates will be removed and only one copy of each value will be kept in the set, as in the example of the name string Sumantra. So let's see one more example. Create a set from an iterable with duplicates. Let's create a duplicates variable initialized to list of duplicate values. Now create a sets using set function, passing duplicates variable, and let's print it. So now we run it. So we have created a set named sets that contains only 3 elements, 1, 2, and 3. And all the duplicates elements have been removed from the set. How do we access elements in sets? Sets are unordered collections, which means that we cannot access the elements in a set by using their position or index. However, we can use the in operator to check if an element exists in a set or not. Let's see an example. Let's again create set variable fruit with element apple, banana, and cherry. So if I check apple in fruits and print its output, we'll get a true. Similarly, if we check grape in fruit, we'll get a false output. So the in operator basically checks if an element exists in a set or not. So how do we change or modify elements in sets? Sets are mutable collections, which means that we can add or remove elements from the set after it is created. However, we cannot change or modify existing element in a set because they are immutable. To add an element to a set, we can use add method. This method takes one argument, which is the element to be added to the set. For example, fruits.add. Let's add orange element to the set. Now I'll print the fruits. So this is added the string orange in the set of fruits. To add multiple elements to a set at once, we can use update method. This method takes an iterable object as an argument and adds each element of the iterable to the set. For example, fruits.update, we can add mango, grape, pear. So this line will add multiple elements to a set. Let's print the fruits. And if I run it, you will see characters G or character string G, E, A, N, R, O, P, M has been added from the string mango, grape, and pear. But this is not the functionality we are expecting because we wanted to add mango, grape, and pear as an element. So for that, we have to use list iterable so that the iterable elements can be taken as character strings such as mango, grape, and pear. Now again, if we run it, we'll get the desired output, which is apple, cherry, pear, grape, mango, and banana. To remove an element from a set, we can use remove method. This method takes one argument, which is the element to be removed from the set. For example, let's say I want to remove banana from the set. So this line will remove banana element from the set. Let's run it. So you can see this has removed the string banana from the set fruit. Note that if you try to remove an element that does not exist in the set, the remove method will raise a key error. For example, if I try to remove an element which is not there in the fruits set, let's say orange, and if we run it, so you can note that this is going to raise a key error, orange. To avoid this error, you can use discard method instead. This method also takes one argument, which is the element to be removed from the set. However, if the element does not exist in the set, the discard method will do nothing and not raise an error. For example, if instead of remove, we run discard, so it has not removed the element because it was not existing and it has not raised an error. Let's check whether discards really remove element. And now over here, I have discarded apple from the fruit set and then again discarded orange, which is not there in the fruit set, and we'll see what's the output of the fruit set. So you can see if element exists in the set, discard will successfully remove that element. Otherwise, it will do nothing and will not raise an error. To remove and return an arbitrary element from a set, we use the pop method. This method does not take any arguments and returns one element from the set. The element that is returned is unpredictable because sets are unordered. For example, let's define a variable fruit and pop an element from a set. Now, if I print fruit, it is popping out banana from the set. Let's see one more time. So see, this time the pop method has popped apple instead of banana. This is totally arbitrary and unpredictable because sets are unordered pair. Note that if you try to pop an element from an empty set, again the pop will raise a key error. So if I initialize fruits as an empty set by using set function and comment this and then run this line of code, then you'll get a key error which says pop from an empty set. To remove all the elements from a set, we can use clear method. This method does not take any argument and does not return anything. It simply empties the set. For example, let's again reassign apple, banana, and cherry to our fruit set. Remove this method and then call clear and run it. So you can see this is removing all the elements from the set fruits and printing an empty set. How do we perform mathematical operations on sets? Sets are typically used for mathematical operations like union, intersection, difference, and symmetric difference. These operations can be performed by using either operators or methods. The union operation returns a new set that contains all the elements that are in either of the two sets. To perform union using operators, we can use union operator, which is represented by bar character, and to perform union using methods, we can use union method. So for example, let's create a set of element 1, 2, 3 and naming it as A, and another having 3, 4, 5, naming it as B. So if we do C assign A union operator represented by a bar character B, so this will perform union on the set A and B. Let's print it. So you can see this has resulted in A union B of set 1, 2, 3 and 3, 4, 5, which is 1, 2, 3, 4, 5. We can also do union operation using union method, union B. And if we run it, so you can see both these examples are returning a new set that contains all the elements that are in either A or B, that is 1, 2, 3, 4 and 5. The intersection operation returns a new set that contains only the elements that are in both of the two sets. To perform intersection using operators, we can use the intersection operator denoted by AND character, and to perform intersection using methods, we can use intersection method. For example, in this case, if we change bar to AND and then print the resulting set, we'll get 3, which is common in set A and set B, both. So basically, this is performing the intersection on set using operators. Let's perform intersection on sets A and B using intersection method. A dot intersection B and then print C1. And now we run it. So both of these examples are returning a new set that contains only the elements that are in both A and B, which is 3. The difference operation returned a new set that contains only the elements that are in the first set but not in the second set. To perform difference using operators, we can use difference operator, which is denoted by minus or dash sign. And to perform difference using methods, we can use difference method. Let's see the example. Again, if I change intersection operator with minus sign and then print the resulting set, run the program, so you'll see it print all the elements that are in A but not in B. So 3 is A and B both, so it's not printed. Similarly, let's perform difference on sets using difference method. So over here, A difference B, and let's print C1, which is again giving 1 and 2. So over here, both of the examples are returning a new set C or C1 that contains only the elements that are in A but not in B, which are 1 and 2. The symmetric difference operation returns a new set that contains only the elements that are in either of the two sets but not in both. To perform symmetric difference using operators, we can use the symmetric difference operator denoted by caret character, and to perform symmetric difference using methods, we can use symmetric difference method. Let's see again the example by modifying the following code. So if I remove difference and change it to caret operator, which can be inputted using Shift 6 in your keyboard, and then print the resulting set. So this is performing symmetric difference on sets using caret or symmetric difference operator. To perform symmetric difference on sets using methods, we can use a dot symmetric difference b and then print and run it. So we can see in both the examples, we are getting a new set that contains only the elements that are in either A or B, but not in both, which are 1, 2, 4, 5. How do we compare sets with other data types? Sets and other data types have some differences and similarities that make them suitable for different purposes. The main difference between sets and other data type is that sets are unordered and do not allow duplicate values, while other data types are ordered and allow duplicate values. This means that sets do not have a specific position or index for each element, and you cannot have two elements with the same value in a set. Other data types have a specific position or index for each element, and you can have multiple elements with the same value in the other data types. This also affects the operation that can be performed on sets and other data types. Sets can perform mathematical operations like union, intersection, difference, and symmetric difference, which are based on membership and uniqueness of the elements. Other data types can perform operations like concatenation, repetition, slicing, and indexing, which are based on order and position of the elements. Another difference between sets and other data types is that sets are mutable and other data types are either mutable or immutable. This means that sets can be changed, modified, or deleted after they are created, while other data types can either be changed or not changed after they are created. Mutable data types include lists, dictionaries, and our own sets, and immutable data types include strings, number, tuples, and frozen sets. So what are frozen sets? Frozen set is a special type of set that is immutable. It has same properties as set, except that it cannot be changed or modified after it is created. You can create frozen set by using frozen set function with an iterable object as an argument. Let's see an example. To create a frozen set fruits, we'll use frozen set method and we'll pass the list iterable apple, banana, and cherry as its element. Now let's print the fruits. So this will create frozen set named fruit that contains 3 strings, apple, banana, and cherry. And we can see it by printing the fruits variable. However, you cannot add or remove elements from a frozen set. If you try to do so, Python will raise an error. So if I try to add orange in the frozen set and try to run it, this will raise an attribute error. Frozen set object has no attribute add. This means that frozen sets do not have methods like add, update, remove, or pop that can modify the elements. You should use frozen set when you want to store data that is unique and does not need to be changed throughout the execution of the program. You can also use frozen sets as key in a dictionary or as an element in another set. Now that you have learned about sets in Python, it's time to practice your skill with hands-on exercise. In this exercise, you'll be given a task to write a program that uses the concepts that we have learned today, and you can use any of the variables, data types, operators, and type conversion function that we have learned earlier. You can also use input function to get the user input as a string and print function to display the output. So write a program that takes 2 sets from the user as input separated by commas and print their union. Let's code the solution of the program. Our first step is asking the user to enter the first set and converting it into a set of strings. So we'll create a variable set1. We'll use input function and give the prompt. Enter the first set separated by commas, colon. And then we'll convert this input to a list of element using split function on comma. And then we'll pass it as an input to the set function to create set1. Similarly, the next step is to asking the user to enter the second set and converting it to a set of string. So we'll just copy paste the above code of set1 and change it to set2 and prompt second set. Over here also, we'll first create a list of strings using split function on set2 and then passing it to the set function. The next step is to calculate the union of two sets using union operator, or you can use union method too. So union operator is represented by a bar character. So we have to just write union set1 bar or union operator set2. And finally, we'll be printing the union of the set1 and set2 using string formatting. Print, we'll use f string. The union of the two sets is, we'll pass union variable inside curly bracket, and that's it. Now I'll run the program. 7, second set. So you can see the union of the two sets are 3, 7, 2, 6, 4, 9, 8. And the order is not maintained. It's an unordered data type. We'll run one more time. 1, 2, 4, 6, 8 as a first set of inputs. 2, 4, 9. Again, you can see we got the union of first set and second set as 8, 4, 6, 1, 9, and 2. This concludes our session for today. We have learned Python sets and how they are different from other data types. In the next episodes, we'll learn about Python dictionaries and dictionary methods. If you have any questions or feedback, please let me know in the comments below. Thanks for tuning into Sumantra Codes. If you found this helpful, give it a thumbs up and subscribe for more coding tutorial tips and tech insights. Hit the notification bell too, and let's continue this coding journey together. Stay tuned.